Hello, my totally sane IT enjoyers. Let's talk about logs, the holy essence of digital life. Good logs can save you hours of debugging, calm your mind better than the silly pills the nice people in white coats keep handing me, and preserve the last few brain cells you've got. Since the average gay candidate can't hit their mouse with a spoon on the first try, and when faced with a shape sorter they act like it's Pandora's box of unspeakable horrors, those who can actually read and write are instantly seen as prodigies and get rewarded with a comfy IT salary. And logging is all about reading, because when something breaks, and it always does, good logs let you understand what happened without digging through spaghetti code for hours. So today, in this cozy little session at the IT Asylum, we are going to break down logging in your test automation framework. We'll cover what's worth logging and what's not, how to organize your logs so they don't look like a schizophrenic chat dump, and of course, where to store them so future you won't cry in a corner. Okay, what should you log? Short answer here is yes. Longer answer, everything that gives context. When something breaks, any small detail might help you understand the root cause. In test automation, here's what you should definitely log. Any interaction with the system under test, any business logic calculations, every assertion or validation, ideally every function call with its parameters. Let's compare logs from two test runs. Examples will be in Python using Loguru, but the logic applies to pretty much any language or logging tool. First, here's a run with no logs. You only see failure, and I doubt you can say with high confidence what exactly went wrong. Can you tell me if it's an app or testing framework issue? Where do you need to make a fix? This is extremely simple and short test, and if it was a real-life complex one, you would have many troubles finding out what went wrong. Now, here's the same test but with logs turned on. If you put a video on pause and read through logs carefully, you'll be able to find out where the issue is. Based on logs, service created two posts with the same ID, or at least same ID was returned for two different posts. You don't even need to look at the code to tell me what's wrong, which saves you hours if not days on work. There are many levels of logging, and they can slightly differ depending on programming language and login tool you use. You can also introduce your own levels if needed for more precise logging. Typically, there are 6 levels. The fatal or critical log level is reserved for recording most severe issues that require immediate reaction. Such entries are logged just before your code crashes. Usually, there are notifications configured if such entries appear to provide instant alerts so that team members can react promptly and take necessary actions. Typically include the following. Crucial configuration information is missing, loss of essential dependency or services. The error log level indicates error conditions that we expect, typically include the following: external APIs or services failures impacting the test, network issues, failure to create, read, update, or delete a resource, when we fail to decode or encode something. Events logged at warning level show that something unexpected has occurred, but code can continue to run. We also use it to highlight events that are not following acceptance criteria. Typically include the following: errors that we can recover from, outdated configuration settings or function calls, external API response times exceed acceptable thresholds. The info level captures events in the system that are significant to the business logic. Such events are logged to show that the system is operating normally. Typically include the following: progress updates, records of important milestones. The debug level is used to help us identify issues during a debugging session. The content of the messages logged at the debug level will vary depending on your application, but they typically contain detailed information that assists its developers in troubleshooting problems efficiently. Typically include the following: database queries, API requests and responses, timing information such as duration of specific operation or methods execution. The trace level is designed specifically for tracing the path of code execution within a program. It is primarily used to provide a detailed breakdown of all the events that took place during the test run. Typically include the following: when entering or exiting from a function or method along with any relevant parameters or return values. calculations of operations that produce specific output or intermediate results. When you start logging so many things, your files will quickly turn into an unreadable mess. Just random messages flying around like hallucinations when you forget your meds. That's where structure comes in. I recommend organizing logs in 3 layers. First layer, high-level overview. These are logs from info to critical. They describe the flow at a high level. What test started, what was the result, key milestones. This is what you'd share with developers, managers, or anyone who doesn't want to dig into details. If they can understand your logs, you've done a great job. Second layer, debugging level. More detailed messages, usually printed to the console while the test runs, they help you trace what happened and fix most common issues. Third layer, deep trace. This includes everything, from trace to critical. It's saved to a file. You'll thank yourself when a weird flaky bug shows up that you can't reproduce, and this file saves the day. Log structure is great, but you also need to store logs in the right place. Here's how I map storage to the 3 log layers. First layer, logs. These should be shareable and easy to explore, so we use tools like Splunk, Elasticsearch plus Kibana, ClickHouse. All of them let you search and visualize logs beautifully. Combine them with test reports and your team suddenly knows what's going on. You can also use tools like Fluentbit to monitor log files and send logs to any of the mentioned destinations automatically. Second layer, logs. These are mostly printed to console. They are for local debugging, but you can also duplicate them into a file if needed, especially for CI pipelines or long runs. Third layer, logs. These are full, raw logs. They are too detailed for most people, but you still want to keep them for hard to reproduce bugs. Store them in S3 buckets, Artifactory, your favorite log archive solution. No need for fancy dashboards here, just make sure they are not lost. Logs are incredibly powerful. They let you understand and debug your tests with just a glance, no code diving. In a way, logs are like the voices in your head, annoying but incredibly helpful if you know how to listen. There's no single perfect way to do logging. What I've shown today is just a summary of the nightmares I've had trying to debug huge systems without logs. Hopefully you can avoid some of that pain. That's it for today's Mad Party. Stay sane, coders, and may your logs be ever readable.